Moving coil galvanometer. Moving coil galvanometer is a device used for measuring the current in a circuit. Principle. Moving coil galvanometer works on the principle that a current carrying coil placed in a magnetic field experiences a torque. Construction. It consists of a rectangular coil of a large number of turns of thin insulated copper wire wound over a light metallic frame. The coil is suspended between the pole pieces of a horseshoe magnet by a fine phosphor bronze strip from a movable torsion head. The lower end of the coil is connected to a hairspring of phosphor bronze having only a few turns. The other end of the spring is connected to a binding screw. A soft iron cylinder is placed symmetrically inside the coil. The hemispherical magnetic poles produce a radial magnetic field in which the plane of the coil is parallel to the magnetic field in all its positions. A small plane mirror M attached to the suspension wire is used along with a lamp and a scale arrangement to measure the deflection of the coil.
A moving coil galvanometer works on the principle that a current-carrying coil placed in a magnetic field experiences a torque. On your screen, can you see the basic construction of a moving coil galvanometer? It consists of a permanent magnet, a coil wound around a soft iron core. The axis of the core is fixed and attached to a pivot, in turn attached to a pointer through a spring. In order to use the galvanometer, it is attached as you can see in the circuit. On switching the circuit on, the current flows through the circuit. A torque acts on the coil due to the magnetic field, and that causes deflection in the spring and therefore the pointer. The torque is equal to NIAB, where N is the number of turns of the coil, I is the current in the circuit and thus the coil, A is the area of the coil, and B is the strength of the magnetic field. If small k is the torsional constant of the spring and phi is the deflection, we have K phi equals NIAB. The deflection and the current are thus related by the expression phi equals NAB by K into I. And see carefully, this quantity in the bracket is constant for a galvanometer. Thus, using the deflection, we can obtain the current in the circuit.